Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. This question asks in which pairs the second ion is more stable than the first ion. We analyze each pair using aromaticity, Huckel's rule, 4n plus 2 pi electrons for aromatic stability, and carbocation-carbanion stability principles. Pair, I-cyclopropenyl cation versus cyclopropenyl anion. Cyclopropenyl cation, 3-membered ring, 2 pi electrons, n is equal to 0, 4, 0, plus 2 is equal to 2, aromatic very stable. Cyclopropenyl anion, 3-membered ring, 4 pi electrons, 4n with n is equal to 1, anti-aromatic very unstable. Second ion, anion, is less stable than first, cation. Pair I does not qualify. Pair 2-cyclopentadenyl cation versus cyclopentadenyl anion. Cyclopentadenyl cation, 5-membered ring, 4 pi electrons, 4n n is equal to 1, anti-aromatic unstable. Cyclopentadenyl anion, 5-membered ring, 6 pi electrons, 4n plus 2, n is equal to 1, aromatic very stable. Second ion, anion, is more stable than first, cation. Pair 2 qualifies. Pair 3-cycloheptadenyl anion versus cycloheptadenyl cation, propylium-related. Cycloheptadenyl anion, cycloheptaterynyl anion 7-membered ring, 8 pi electrons, 4n n is equal to 2, anti-aromatic unstable. Cycloheptadenyl cation, propylium cation 7-membered ring, 6 pi electrons, 4n plus 2, n is equal to 1, aromatic very stable. Second ion, cation propylium, is more stable than first, anion. Pair 3 qualifies. Pair 4,1-hydroxycyclohexyl cation versus 1-methylcyclohexyl cation. 1-hydroxycyclohexyl cation, the positive charge on carbon-bearing OH lone pair on oxygen can donate into the empty p orbital, providing resonance stabilization, making it an oxocarbenium ion relatively stable. 1-methylcyclohexyl cation, tertiary carbocation stabilized by hyperconjugation induction from methyl group. The OH group's lone pair donation, resonance, generally provides more stabilization to an adjacent carbocation than a methyl group's hyperconjugation. Thus, first ion, OH-bearing cation, is more stable than second, methyl-bearing cation. Second ion is less stable than first. Pair 4 does not qualify. Therefore, only pairs 2 and 3 have the second ion more stable than the first. Therefore, the correct answer is B. Therefore, the correct answer is option B.